we are doing vertex form of quadratic functions. We're going to be doing some completing the square today, and then also looking at the key features of quadratic functions from vertex form. So starting off, we got to make sure you remember how to do completing the square. So remember, this is the one where when you're doing it, you kind of just leave yourself a little blank space, because you're going to be adding something to both sides. And what you're trying to do is to make this a perfect square trinomial. So to do that, kind of have some math tricks for you. We take the square root of this first term, which would just be x. And then we take half of our b term, so that would be -2. And then we just take that number and square it to complete the square. So -2 squared would give us +4. And if I add 4 to the left side, then I have to add 4 to the right side, which would give me 25. And remember, the purpose of completing the square is so that you can make a perfect square trinomial, so that you can write it as a binomial squared, this x minus 2 squared, and then you can use the square roots method, because then we can take the square root of both sides and we end up with x minus 2 equals plus or minus 5. Don't forget your plus and minuses. And then you are going to just set set x minus 2 equal to +5 and -5, and then solve both of those equations. So we would add 2 to the left, and that would give me x equals 7, and then we would add 2 over here, and that would give me x equals -3. Okay? So in this one, to complete the square, we have to move this 17 first. So we would want to subtract 17 from both sides, so that we end up with x squared plus 18x plus something to complete the perfect square, equals -17 plus that something again. And so then we have to figure out what is the binomial that I'm going to be squaring. So we take x and put it there, and then half of my middle term, 18, would be 9. And so then when I write that, that's my binomial, and if I were to square x plus 9 squared, it would give me x squared plus 18x plus 81. And I know that because it's just taking that 9 and squaring it. And so if I add 81 to the left, I have to add 81 to the right, and -17 plus 81 would give you a +64. Ooh, that's a bad 4. There it goes. Not much better, but it's okay. So from there, since we have this x plus 9 squared, we can take the square root so that we can cancel out that squared, and that would leave us with x plus 9 equals positive or -8, because remember, the square root of 64 is 8. And so from there, we set x plus 9 equal to +8 and equal to -8. And then we solve. So on the left one, we are going to subtract 9, and that would give me x equals -1. And on the right equation, when I subtract 9, not 1, that would give me -8 minus 9 is -17. Okay? So remember the purpose of completing the square. Even if you can't remember what you're supposed to do to get the third term, if you can at least remember to take half of your middle term and then square that binomial you get, okay? So now we need to write an equation in point-slope form for a line through the given point. In case you do not remember, point-slope form is y minus y1 equals m, which is your slope, times x minus x1. And remember, in this formula, you're only plugging in your y1, x1, and your m. The x1 and the y1 come from a point where x1 is the x value and y1 is the y value. So if I have the 0.95 and the slope is -6, to plug it into the formula, I would have y minus the y value, so that'd be y minus 5, equals slope, which is -6, times x minus x1, which is 9, so -9. Okay, so I tried to use colors that time so you can kind of see what numbers and things should be changing. There should always be an x and y in your equation, though. Okay, For number 4, you are going to plug in these numbers. Remember, this is x1, this is y1, and then you're going to plug it into the formula. So we would have y minus y1, which is negative 2. Since it's minus negative 2, that would just be y plus 2 equals m, which is 3 times x minus negative 7. And again, since that's a minus negative, that would become a positive like that. Okay, so even though we don't use point slope a ton, you do still want to be familiar with what it looks like and how to use it. Okay, so getting into quadratics, because ultimately that's what all of this is really about, because quadratics are awesome, is that you have vertex form, and it looks kind of crazy when you first see it, so try not to freak out, but it is y equals a times x minus h squared plus k. And the nice thing about vertex form is that it gives you your vertex at hk. And then remember that your a value, we've already talked about it, that's that number in front, determines if it opens up or down, and the width of the parabola, okay? Remember, if it's positive, it opens up. Oops, it's supposed to be different color. Positive number would open up, negative number would open down, okay? So for example 1, we want to identify the opening direction and the width compared to y equals x squared, the coordinates of the vertex, and whether the vertex is a maximum or a minimum. So first off, picking the opening direction, since I have this negative 5 in the front, that is what tells me that this opens down because it's negative. Okay, your a term is negative. A term is negative. Okay. Now, the width compared to x squared, remember when it is a number that's bigger than 1, so 5, that is going to be a vertical stretch. And I know it's kind of hard to, or at least for me, it's hard sometimes to remember like vertical stretches that make it wider or narrower. But remember, think about it. If you are stretching vertically, like with yourself, stretching to touch the sky, you're making yourself narrower in a sense. And if you were trying to vertically shrink yourself, you're trying to make yourself as small as possible. So you'd be stretching yourself out left and right. But since this is a 5, that's going to be a vertical stretch, which means it's narrower. Okay, so just keep in mind that with those, it seems kind of backwards, but just take a second to think about it. But so vertical stretch just means it's narrower. The vertex, remember with vertex form, your x value of your vertex is with the x. So if we look at this equation, the number that's with my x is negative 2, but I want to use the opposite sign of what I see. So even though it's negative 2, my vertex is actually going to be at positive 2. And then this number out here is your y value of your vertex, and that's going to be at positive 1 in this case. And then this vertex, because this parabola opens down, that would mean that it would look like this on a graph. And so if you notice, that is like a roller coaster going up and you're at the top of the hill. So this would be a maximum. Okay. So, boop. With this one, we first want to decide, does it open up or down? Looking at this first number, that tells me that it opens up because it's positive. And then determining if it's wider or narrower than the parent function y equals x squared. Again, you're deciding, is it a vertical stretch or shrink? Since it's bigger than 1, this is going to be a vertical stretch, which means it is narrower. Okay. And so then our vertex for this, remember this is in vertex form, so it's pretty nice because you look at the number that's with the x, it's x plus 4, so I'm going to use the opposite number, and that's going to be negative 4 for the x value. And then my y value would be anything that's added or subtracted to this x plus 4 squared, which there's nothing there. And so the number that's nothing is 0. And then since this opens up, that would mean the parabola would look like this, and that would mean my vertex would be down here, which would be a minimum. Okay. Boop. Now it's supposed to be black. Tried to change the color. Didn't work. All right. So with this last one, y equals negative 1/6 x minus 3 squared minus 7, even though it looks not the prettiest of things. You can identify which way it opens just by looking at the sign of this number. Negative 1/6 tells me that it opens down because it is a negative number. Okay. Now, determining if it is a vertical stretch, wider, or narrower, this number, 1/6, doesn't matter that it's negative, just looking at the number, is less than 1, so that would be a vertical shrink. And remember, if it's a vertical shrink, you're trying to make yourself as short as possible, which means you would be getting wider. Okay, and so then our vertex would be what the number with the x but opposite sign is a -3, so that would be +3. And then the number that's added or subtracted, you just get to keep it as you see it, is -7. So our vertex would be at 3, -7. Since this opens down, this is going to end up being a maximum. And yes, that is always the case. If it opens down, then your vertex is a maximum. Okay. So moving on down. We want to write a quadratic equation for a parabola with the given vertex. So if you have to, feel free to use the previous examples. But if I want my vertex to be at 8, -6, the most simple way to do this would just to be say y equals, the x value would be x minus 8 in there, squared. And then that -6 would just be afterwards, -6. Okay? So if I were to do it with 0, 5, I would have y equals something in parentheses with the x squared, which it's a 0, so I'd have just x squared by itself. You don't even need parentheses with this one. And then since the y value is 5, you would have plus 5. So with vertex form, you do not have to write it as x minus 0 squared plus 5. Not needed. Don't do that. You can just write it as x squared plus 5, and that's fine. So with the last one, we would have y equals, x value first would be -1, so we'd have x minus -1, which would be x plus 1 squared. And then the 9 would just get added off to the end like that. Okay? So the question is, are these the only quadratic equations with graphs with these vertices, and why? Well, if you think about it, all of these graphs, I can graph all of these. But if you look up at the ones that we were just doing before it, we were adding numbers in front of them, which means they would, even though these vertices in example 2 don't match the vertices from example 1, I could change these equations and add numbers in front of the x squared and still have the same vertex, but just change its width. So to answer the question, no. You can change the value of the A term to change opening and width. Okay. So for the next one, oops, that got funky. So for examples 3 to 5, we are going to use completing the square to help us write a quadratic equation in vertex form and identify the vertex. Then we're going to decide if it's a minimum or maximum and state the value. Now, here's the thing. Even though it sounds really hard, it's really not if you just pretend like y is a number for a little bit that you just can't add to. Okay, so if we look at this y equals x squared plus 6x plus 7, if I were completing the square, I know that I would ultimately need this x squared plus 6x to be by itself, right? I need to have plus some mystery number. So that means I'm going to have to subtract 7. Okay? When I do that, that means on the left side of this, I would have y minus 7 because I can't combine y and 7 yet. Okay? Now, I know some of you are probably like, what the heck is happening? But remember, I'm still going to be adding something, mystery thing, to both sides, okay? So from here, I'm going to figure out what binomial I will be squaring. And so I will take the square root of this x squared, which is x, and then I'll take half of this 6, which is 3. And then to complete my square, I am squaring that 3 to make it 9. If I add 9 to the right, I'm adding 9 to the left. And if I'm adding 9 to the left, now I can combine something with that 7. And that would give me negative 7 plus 9 would be positive 2, not negative 2. Whew. So then I would have y plus 2 equals x plus 3 squared. Okay? Now, this is where you kind of have to stop yourself from wanting to finish completing the square. And instead of taking the square root, now because we're trying to keep it in vertex form, we are just going to move this plus 2 over to the other side because ultimately I just need the y value by itself. Okay? In algebra, probably one of the best skills you can develop is your ability to manipulate things. But with this x plus 3 squared and the minus 2, we can't combine them because the x plus 3 squared is by itself. And for vertex form, we wouldn't want to anyways. So then we would be left with this left over, and this should look like vertex form to you, which hopefully it does. I know it still probably looks kind of strange to some of you, and that's fine, but you really do have to force yourself to practice this to get used to it. So with this, now that I have it in vertex form, I can identify my vertex. Don't get too letters to change the colors that time. So my vertex with my x value, it's going to be with the x itself. So since it's positive 3, my vertex is at negative 3. And then my y value is just the number I see that's added or subtracted at the end. So that's just going to be negative 2, the end. Yay! Now, determining if it is a maximum or minimum, you have to look at your a term. Hopefully, you could have just looked at it and decided this ahead of time, but when we first started, the a term was a positive 1. Even down here, it's still a positive 1, which means that this would be opening up like a regular parabola, which means this vertex is a minimum. Okay? So, from there, and also when we talk about like minimum values, we're usually talking about the y value, so we would say negative 2. Okay? Okay, so for number 4, we are still going to be completing the square, but remember it just looks kind of funky. So first we're going to add this 8 so we can get it by itself, or get the x squared minus 2x by itself. So we would have y plus 8 plus that mystery thing that comes from completing the square equals x squared minus 2x plus mystery thing. Okay? And so on the left, it doesn't really change, unfortunately, but on the right, we can change it to be, actually, I guess I don't need to write that part yet, but square root of x squared is x, and negative 2x, half of negative 2 would be negative 1, and negative 1 squared would give us positive 1. So I'm going to be adding that to both sides. So then 8 plus 1 would be 9, like that. And so then putting this into vertex form, I would just want to move that 9 to the other side, so I would just subtract it. And so then y is going to equal x minus 1 squared minus 9. Okay? So then my vertex is going to be based off of this. So remember, x value is with the x, but opposite. So negative 1 would become a positive 1, and then your y value is just the way you see it, which would be negative 9. And then because, again, deciding if it's a maximum or minimum, you can do it first step. That's a positive 1. Even in vertex form, it's still a positive 1, which means this would be opening up, which would give me a minimum. All right, so for example 5, we are going to be completing the square one more time. So remember, we want to get the 31 away from all of that. So minus 31. That would give me y minus 31 equals x squared. Ooh, I didn't leave myself space. What am I doing? Plus something equals x squared minus 10x plus something. Honestly, for me, sometimes it just helps me remember what I'm doing to include those plus somethings. But without further ado, to finish this, we need to complete our square. So the square root of x squared is just x, and then half of this 10x would be 5. And so then negative 5 squared would give us positive 25. So then that gives me negative 31 plus 25 would give me negative 6. So that would be y minus 6. And then to finish putting it into a vertex form, we would just add the 6 to both sides. And so then we would have y equals x minus 5 squared plus 6. So then your vertex would be the x values with the x but opposite. So negative 5 would be positive 5, and then y values as you see it. So it'd be at positive 5, 6. And then this would also open up because the a value is positive. That's a positive x squared. And so this would be a minimum again. Okay. So the closure question is to explain how the graph of y equals negative 7x plus 1 squared minus 4 compares to the graph of y equals x squared. Refer to opening, the width, the coordinates of the vertex, and whether the vertex is a maximum or a minimum. So with this y equals negative 7x plus 1, all that, blah, blah, blah. Okay. The negative 7 helps tell you your opening direction and your width, okay? And also helps you decide if it's a maximum or a minimum, okay? So if you like color coordinating, that is the stuff that would go with opening direction, okay? Or with the negative 7, your A term. So in this case, because it's a negative 7, that means it would open down. Since it opens down, that'd be like this, which means I would have a maximum. And then on top of that, because it's a 7, it's bigger than 1, which means it's a vertical stretch, which means it's gotten narrower. Okay? Now, the vertex comes from the other numbers. Okay? So that would be the negative or the positive 1 and the negative 4. So our vertex for this new one would be at negative 1, negative 4, because remember, x value is opposite, y value is how you see it. And we've already decided that it is a maximum. Now, compared to x squared, keep in mind, and I'm going to do all the x squared stuff in purple, but y equals x squared opens up, has a minimum at 0, 0, and it is the same width of itself, obviously, because it's the same function. Okay, so if you have any questions, feel free to comment below or send me a message, or however you can get in contact with me. I am more than happy to answer your questions. I just need to know you have them. Also, check out the live streaming, check out the times and everything when we'll be on. If this video was helpful at all or anything, please like it, and feel free to subscribe to the channel if you want to get notifications when more math videos get posted. I will see you all later, and I hope you are all staying safe and far away from other people during this lovely time.